All right, we're going to work on using formulas for a second day here. Today, we're going to look at dimensional analysis. Dimensional analysis, or what's sometimes called unit analysis, is just the process of performing operations within units. And what that means is we'll be given units to start with, and we'll be asked to maybe answer a question in a different set of units. And we have to think about how we're going to make that conversion throughout the process. So, as we're given a problem that involves dimensional analysis, you need to start thinking ahead a little bit. Number one, what units are we given? Two, what units do they want in the solution? And third, what steps are we going to have to take to make the conversion from what we're given to what we want to have in the end? And this is where we're going to need to know a little bit about our units in terms of how do we make the conversions? What are the most common ones that we use? This stuff you may want to have written down in your notes so you can use them to help you with the setup and the execution of these. All right, so first of all, let's look at this first question here. It says a bike track has a length of 2,112 feet. How long is this in miles? So they're going to ask us to first fill in the blank on the left side of the equation using one of the ratios and then write our answer on the right side of the equation. What I want to just look at quick, and it's the same thing they have there, is we're starting out with 2,112 feet and we want to end up in miles. So what we're looking at is we're going to multiply this 2,112 feet over one, this fraction, by another fraction that's equal to one so that we can cancel out the feet and are left with miles. So what we're looking for is one of the ratios up here that have miles over feet. Okay, so all of these ratios up here are equal to 1. 1 yard is the same as 36 inches, so that's equal to 1. 36 inches is the same as a yard, so that's equal to 1. 5,280 feet is the same as 1 mile. 1 mile is the same as 5,280 feet. A mile is the same as 1,760 yards, and then 1,760 yards is the same as a mile. All of these are equal to 1. So if I multiply this by 1, it equals the same amount. We have a property that says that. So what we're looking for here is which one of the ratios will be miles over feet so that I can cancel my units of feet and I'm left with miles. And it's 1 mile over 5,280 feet. Okay, the feet is what's going to cancel out. I'm left with miles. You multiply numerators, denominators. What we're going to wind up doing is taking 2,112 and dividing it by 5,280, and you get zero point 0.4 miles. Okay, so 2,112 feet is the same as zero point 0.4 miles. Again, we looked for a ratio that would allow us to cancel the units that we're given and leave us with the units we want. Okay, let's take a look at another one. A runner sprinted 159 yards. How many feet is this? So we're starting with yards. And we want to get to feet. So I'm looking for a ratio that is feet over yards so I can cancel my yards. So if I go up here, okay, I got 3 feet equals 1 yard, correct? So 3 feet equals 1 yard. So this ratio of 3 feet to 1 yard is equal to 1. So I'm multiplying this by 1. So it's going to be equal on this side. The yards are going to cancel. And 3 times 59 is 477. So there's 477 feet in 159 yards. Okay, this is just the thought process here. Okay, now let's apply it to some situations. So we got a car that's traveling 60 miles an hour. What is the car's rate in kilometers per hour? And then how many kilometers will the car travel in 4 hours? In your computations, assume that 1 mile is equal to 1.6 kilometers. Do not round your answers. Okay, so the first thing we got to do is convert miles per hour to kilometers per hour. So we're given 60 miles per hour. That's what this means. The ratio of 60 miles to 1 hour. Okay, we want to convert this to kilometers per hour. So our ratio of miles to kilometers is what we want to use here, but we want to write it so that we're canceling out miles and we're left with kilometers per hour. So I'm going to write this as 1.6 kilometers to 1 mile. They're saying these are equal, so this is like equals 1. I wrote it as kilometer over miles because I want my miles to cancel. Then I'm left with kilometers as a unit at the top. Hours is the unit in the bottom, which is kilometers per hour. So multiply numerators and denominators, and we're going to get 96 kilometers per hour. Okay. So 60 miles per hour is the same as 96 kilometers in 1 hour. And it's all about writing this ratio so we can cancel out the units we want to get rid of and we're left with the units we want. Okay, now at our new rate, how many kilometers will we go in 4 hours? So if we go 96 kilometers in 1 hour, how many would we go in four? So I wrote 4/1. Okay, cancel out the hours. I'm left with kilometers, and it's 4 times 96. So this is 384 kilometers. Okay, our hours canceled. Our answer was in kilometers because it asked how many kilometers would we go in 4 hours. Another example, a swim race has a total distance of 225.5 miles, or excuse me, 22.5 miles. They want to mark the course every 60 yards with a buoy, including one at the finish line. The starting line does not need one. How many buoys are needed? Okay, so where units are in miles, okay, the distance is in miles, but we want to mark it off in yards. So the first thing we got to do is convert 22.5 miles to yards. All right, so 22.5 miles, I want to convert to yards. So I want to cancel out miles and be left with yards. Okay, so I know there's 1,760 yards in a mile. I wrote it like this. I wanted the miles in the denominator, so I'd cancel the miles out. And now it's 225 times 1,760. That's 39,600 yards. Notice yards is my only unit left. I had no unit in this denominator. I canceled out miles. I'm left with yards. Now they want one buoy every 600 yards. Now I did this the simple way. I took the total yards I had, divided it by 600, and we're going to need 66 buoys for this race. Okay. Teresa's uncle from Japan promised to give her 35 grams of gold. That's grams. The local jewelry exchange will buy 100 or will buy the gold for $1,224 per ounce. How much money can she get for selling the gold? 1 ounce is the same as 28 grams. Okay, we're not going to round anything here. So she's given it in terms of grams and she wants to sell it and it's going to be done per ounce. So the first thing we got to do is convert grams to ounces. So she's given 35 grams. That's over one. 35 grams over one is the same as 35 grams. Now I'm going to multiply it so I have ounces in the top, grams in the bottom, so I can cancel the grams out. So it's 1 ounce equals 27 grams. Now the grams will cancel. My answer will be in terms of ounces. So it's going to be 35 ounces over 28. 35 divided by 28 is 1.25. So this 35 grams converts to 1.25 ounces. Okay, now we want to determine the exchange rate. Well, they're going to give us 1,000, or I'm going to take my 1.25 ounces. They're giving us $1,224 for every ounce. So again, I want dollars over ounces, so my ounces will cancel. Okay, 1.25 ounces over one, $1,224 over 1 ounce. Ounces cancel, multiply numerators, $1,530 is what she's going to get. Okay, Maria's dog needs medication. She told the veterinarian the dog weighs 50 pounds. The medicine is measured as 14 milligrams for each kilogram of the animal's mass. That means mass means weight. How much medicine should be given to Maria's dog? That should be a lowercase s and that should be an A. All right. So we're told 1 pound is the same as 0.45 kilograms. All right. So the first thing we got to do is convert the dog's weight from pounds to kilograms. So the dog weighs 50 pounds over one times. Now, what's my conversion rate? Well, it's 1 pound is 0.45 kilograms, but I want to write it so pounds is the bottom and kilograms is at the top so I can cancel my pounds out to convert it to kilograms. So I'm going to write 0.45 kilograms over 1 pound. The pounds cancel. 50 times 0.45. The dog's weight converts to 22.5 kilograms. Okay, so that's the number we have to use to figure out how much medicine. All right, let's determine the dosage amount based on the dog's new weight in kilograms. Okay, so the dog weighs 22.5 kilograms over one. The dosage rate back up here is 14 milligrams for each kilogram. So I'm going to go 14 milligrams per 1 kilogram. Again, I do this so that my kilograms cancel. And now my answer is in terms of the milligrams. So the dog should be getting 315 milligrams of medicine based on its weight. Okay, all unit analysis. Last one, a little more complicated. So we got a parachutist, and their rate during a free fall reaches 117 miles per hour. They want us to convert this rate into feet per second. And then at this rate, how many feet will the parachutist fall in 2 seconds? In your computations, use the fact that 1 mile is equal to 5,280 feet. Don't round your answer. Okay, now this one's unique because we're going to start out in miles per hour, and we got to convert this down to feet per second. So both the top unit and the bottom unit need to change. Miles need to change to feet, hours need to change to seconds. So I'm going to need two different conversions here. The first one is I'm going to go 5,280 feet over 1 mile. My miles will cancel, and now I'll have this in terms of feet. The second one I need to do is convert hours to second. In 1 hour, there's 3,600 seconds, 60 seconds in a minute, 60 minutes in an hour, 60 times 60, 3,600 seconds. Now, the reason it's set up like this is so miles cancel, hours cancel, and the units I'm left with is feet per second. And that's what we're trying to convert. So it took two different unit conversions here. All right, now multiply the numerators together and the denominators together. We get 617,760 feet in 3,600 seconds. If I divide the top by the bottom, it's 171.6 feet per second is what you would be falling. Okay, so that took two different rates to help convert. All right, how far would this parachutist fall in 2 seconds based on this new feet per second measure? So we know it's 171.6 feet in 1 second times 2 seconds over one. The seconds cancel, and I'm left with 2 times 171.6, or 343.2 feet is how far this person would drop in 2 seconds. All right, so that took a little bit more, same concept in the end. All right, so I want you to go in there and to work on your homework tonight on Alex. This is using dimensional analysis, which is pretty straightforward. Have your units of measure written down so you can use them, you can see them, it'll help you with it. You're not guessing. And make sure you're writing out work to support your answers. All right, I'll let you have at it.